Okay, we've got another question here for displacement time graphs. This is S in meters and this is time in seconds. So the question reads, a scooter accelerates from rest 100 meters before the traffic lights at a constant rate of 1.5 until it reaches 6 meters per second. It then travels at this speed until it reaches a point 50 meters beyond the traffic lights. Then it starts to slow down at a rate of 1 meter per second until it stops. So let's look at how we can draw this. So this time we're not starting at 0, we're actually starting 100 meters before something. So we're actually going to be like negative 100. We're 100 meters behind an object. That's where we're starting out. They tell us that it accelerates. So if the object is accelerating, the gradient must start out as because the gradient is speed. So the speed must start out low and then increase, or the gradient must start out low and then slowly increase, something like that. Yeah, the gradient is gonna do that and slowly increase, something like that. Like that. And then after that it reaches 6 meters per second, and they tell us after it reaches 6 meters per second it stays at a constant speed. Constant speed means constant gradient, so then we need a straight line because the line is what has constant gradient, so something like that. And then they tell us after it reaches a point 50 meters beyond the traffic lights. So at this point it should be 50 meters but in front of the traffic lights. So we have a straight line to show constant speed, and then it ends at 50 meters ahead of the traffic lights. Then it starts to slow down, so the speed is reducing. If speed is reducing, we want the gradient to reduce. Gradient reducing, it's gonna start from a high gradient or steep and then end up like that. That zero gradient is a horizontal line. So have it like that, slow down and then 0. And that's the general sketch. Now we need to get some figures. We need to get the time at which it finally stops. We need to get the time at which it gets to 0 displacement. Those are the most important times here. So how can we do that? Let's see. Let's start with the first few seconds. So that a scooter accelerates from rest, so that's our initial velocity, 100 meters before the traffic lights at a constant rate of 1.5 until it reaches 6 meters per second. So the acceleration is 1.5 and the final velocity is 6, right? And right, so we need to figure out how much distance does it cover in the time. You might make the mistake of saying that while it's accelerating it reaches 100 meters, but we don't know. It's possible that the traffic lights are here and then the object starts there and then it speeds up and then it reaches the constant speed somewhere there, maybe 6 meters per second before it actually reaches the traffic lights, because reaching the traffic lights, that will be 0 displacement when it reaches the traffic lights. So what can we do here? We need to find the displacement covered in that from there. So we can calculate it. We're gonna use v squared equals u squared plus 2s. So v is 6, so 6 squared is equal to 0 squared plus 2 times 1.5 s. You'll end up with 36 is equal to 3s, and then s is equal to 12. So that means that from here to here, from the whole acceleration part, this whole part all the way there, let me just label it with a different color. Let me label it with a different color like that. It only covers 12 meters till it stops the acceleration. So if it started at negative 100 and it covered 12 meters as it approached the traffic lights, it was initially 100 meters away. Now it gets 10 meters closer, so we're gonna get negative 100 plus 12. What do we get? Negative 100 plus 12. That gives us negative 88. So there it should be at negative 88. That's when it stops accelerating and it starts moving at a constant speed. Negative 88. Let me just write that a little bit better. Negative 88. Right there. negative 88 meters away from the 88 meters from the traffic lights, it stops accelerating and it moves at a constant speed. But we can also figure out the time. Let's find the time at which it does that. We're going to need to use a different formula to find the time. So let's get the pen and draw that. So to find the time, I'm going to say t is equal to v minus u over a, which is equal to 6 minus 0 over 1.5, which is equal to 4. So it takes 4 seconds to do this whole accelerate till it starts the constant gradient part, the straight line. So it takes 4 seconds and it covers 12 meters, and that's the first part. Then from there it travels at a constant speed until it reaches 50 meters ahead of the traffic lights. So we need to think about this carefully. Let me draw an image here. So the object is now 88 meters away from the finish line, from the traffic lights. So 88 meters away. Then it's going to travel all the way until it's 50 meters ahead. So at constant speed it's going to travel the 88 meters to get there, and then another 50 meters. So in total it's going to travel 88 plus 50 meters, or 138 meters. So that's when it will reach 50 meters beyond the traffic lights. That's the point at which it will start to slow down. So that's the idea here that you're going to use. So it needs to cover 138 meters at the constant speed of 6 meters per second. So we need to figure out how much time it takes it to do that. So let's see. So if you need to cover 138 meters and you're moving at a constant speed of 6 meters per second, we need to calculate the time. So that the displacement is 138, the initial velocity is 6, constant velocity means the acceleration is 0. So s equals u t plus half at squared. Well, the half at squared, the acceleration is 0, so this whole thing cancels out. So half 138 is equal to 60. So what's 138 divided by 6? It's 23. So that time is 23. So it takes 23 to get from 88, reach the finish line, and then get from the finish line and cover another 50 meters. So it takes 23 seconds. So if we had already covered 4, now we need to add on 23, because the 23 is just for the section when it was at a constant speed. So that gives us 27. So before it starts decelerating, it should be time 27, and the displacement is 50 ahead of the light of the traffic lights. Now what's the next thing we need to think about? The next thing is the last part where it decelerates. Let's try to calculate that. So for the decelerating section, let's see what happens. So for the decelerating section, we're gonna use the Suvat equations again. So what next? It slows down at a constant rate of 1 meter. So here we're gonna actually use a -1 to show that it's slowing down until it stops. So the final velocity needs to be 0. Then the initial velocity will be the same velocity with which it was moving at a constant speed, and that was 6. It was moving with a speed of constant 6, and then it started to slow down, so the initial should be 6. Then we need to figure out the displacement, and then we also need to figure out the time. So time is the easier one to figure out. Here it will be v minus u over a, or 0 minus 6, which is -6 over -1, which is 6 seconds. So it takes 6 seconds to get from there to there, to slow down. So we need to get 27 plus 6, which will be 33. Time is 33. And we need to also figure out the displacement. I'm going to use a different formula. I think we can use the v squared formula. V squared equals u squared plus 2as. So 0 is equal to 36 plus 2 times -1s. Then we'll have 2s is equal to 36. And s is equal to 18. So this is 18 meters for that section. Always remember not to put the 18 right there, pay attention to that initial displacement you already had on your diagram. So if that's 50, you need to get 50 plus 18, which will be 68 meters. And that will be basically the answer for that question. That's it.